Then, in the superconductor state, do electrons continue to move even when no current is applied from the outside? Yes, in the superconducting state, electrons continue to move even if an external current is not applied. Superconductivity is a state exhibited by certain materials at extremely low temperatures, where electrical resistance becomes negligible or nearly zero, allowing electric current to flow with almost no hindrance. In the superconducting state, even without an externally applied current, the electrons in the material can move freely. Therefore, if an external current is applied, the electrons will continue to move without any resistance, leading to a state where the current can flow indefinitely. This condition of unrestricted current flow is known as the superconducting state. Superconductors typically operate at very low temperatures, which limits their practical applications. However, they are considered essential materials in certain fields due to their extremely high electrical conductivity and efficiency. Then, the fact that it became a superconductor at a high temperature by applying a very high pressure means that the arrangement of atoms became constant by the pressure, right? The characteristics of superconductors, including their response to temperature and pressure, are determined by complex interactions. Generally, superconductors exhibit a higher sensitivity to temperature changes. Becoming a superconductor at high temperatures does not necessarily imply a direct relationship with the atomic arrangement. Instead, superconductivity is a state observed in certain materials at extremely low temperatures, where the atomic arrangement may remain less irregular even at higher temperatures. The phenomenon of superconductivity arises from intricate interactions between electrons and the crystal structure, and these interactions vary with temperature. Pressure can also influence the properties of superconductors, but our understanding of superconductors is still an ongoing field of research. Research on superconductors is vital in both fundamental and applied sciences, and more studies are needed. Therefore, while the precise working mechanisms and the relationship with temperature and pressure are not fully established, it is generally true that superconductivity tends to occur at higher temperatures. Isn't it contradictory that heat is generated by electrical resistance and that electrical resistance is reduced by applying heat? The generation of heat due to electrical resistance and the reduction of electrical resistance by applying heat are not contradictory. These are different concepts related to electrical resistance and heat. Generation of heat due to electrical resistance. When an electric current passes through a material with electrical resistance, the current encounters resistance due to interactions between electrons and atoms. During this process, electrons expend energy as they pass through the material, and this energy consumption is converted into heat. Therefore, the flow of current through a circuit or object with electrical resistance is a cause of heat generation. Reduction of electrical resistance by applying heat. Some materials exhibit a decrease in electrical resistance when subjected to heat. This phenomenon is known as negative temperature coefficient, NTC. While most materials typically have a positive temperature coefficient, PTC, where electrical resistance increases with an increase in temperature, certain materials can display an NTC behavior, where electrical resistance decreases as the temperature decreases. Thus, the generation of heat due to electrical resistance and the reduction of electrical resistance by applying heat are separate phenomena and are not contradictory. Heat can influence electrical resistance, and the situations of heat generation and the application of heat are based on different physical principles.